Evolution is driven by people like us. The free thinkers. The game changers. The courageous ones. To improve is to change. To grow is to outlast. So, find the courage inside yourself to throw caution to the wind and call your own shots as we make the leap together. Break free from the confines of society. Create boundary-defying innovations. Redefine traditions and create a new culture built on agility and imagination. We believe each and every one of us can rise to the occasion. To build on our heritage and shape our future. To become the Philippines' first tech-glomerate. Together, we can rewrite the rules in the age of great transformation. Change is not for the faint-hearted. It's for the rebels brave enough to dream it. So, join us in paving the way for a new class of Aboitiz innovators. The great transformation begins with you and me.
Okay, so good day, people, and happy Monday. We would like to welcome everyone once again to our second week of the Risk Awareness Month for 2023 or RAM 2023. So I'm Jerome Pelaez of the Food Group, and I'll be your host for today's session. For this week, our learning sessions will focus on the area of business continuity. As we all know, business continuity plays an important part in risk management. And what better way for us to learn more on this by kicking off today's session with a very important topic. Today, we will talk about resiliency beyond IT disaster recovery. This session will explore more the broader concept of IT resiliency, emphasizing its significance in achieving organizational goals and thriving in the face of evolving risks. We hope this learning session will provide valuable insights to everyone. As you always do, please do not hesitate to ask questions through our Q&A panel below and interact with other participants via Zoom chat. All right, so let's get this session started. To share insights and help us to have a better grasp of today's topic, we invited one of our partners from UBx. He is the Director of Engineering, Data, and AI of UBx Philippines. Prior to UBx, he was the CEO of Enquiro, the data analytics and monetization company of the Globe Group. He was the former head of software engineering for Chicago Board Options Exchange for their Tokyo and Sydney high-frequency stock trading operations. He also was the CEO of Rebar Solutions, a software company he founded in 2015. Our speaker for today is a tech veteran with expertise in digital transformation, software engineering, data analytics for high-performance systems spanning various industries, including telecoms, banking, and capital markets. So, help me in welcoming today's speaker, Mr. Jose Alfonso Reyna. Good day, sir, and welcome. Thank you for joining us today.
Thank you for the introduction, Jerome, and good afternoon to everyone. So today I'll be talking about this title, Resilient Engineering for Systems. I'm trying to go for something light and perhaps just informational, but this kind of topic, especially if we're trying to veer away from your more common or traditional disaster recovery and business continuity, will be highly technical. So just bear with me. Bear with at least the first half of these slides. It might bore you. Hopefully, it will be give you some information or new insights. But the back half of it, I will try to put into context why resilient engineering is very important for a conglomerate or a group of companies that are aspiring to be a leader in technology. So I guess I have to skip this slide because I was already introduced. But I think the last paragraph I want to emphasize, or at the very least, my tenure at SIBO or Chi-X. So I want to highlight those two as far as my experience is concerned, because when it comes to engineering resiliency, most of system design and developing products mainly focus on the functional and basically the business outcomes. When it comes to resiliency, it's about those niche events, those stressful occurrences that normally you don't plan for systems, but you just have to make your system withstand those events. So, for example, I want to know my work at Chi-X or SIBO, because in high-frequency trading, basically, especially for the Tokyo and Sydney markets, it's basically handling hundreds of millions of dollars per day, while in the HFT space, basically microseconds matter, and spikes are actually in the 100,000 transactions per second. It's not your normal systems. The same in my formative years, the same experience also applied when I was still a lead developer for smart communications. So basically, this was, I'm giving away my age here. This was during the telco wars of the early aughts, wherein basically their SMS and calls are abundant. And during this time, the systems that I was handling was basically catering to billions per day, not just millions, not 100 millions, but billions of transactions per day. Very exciting, but yet stressful stuff. You have to be as resilient, basically, as the systems that you build during that time. So resiliency is a very big topic, depending as well on the nature of the business and consequently the nature of the systems and the engineering required to support it. Since this is just a 1-hour presentation, I'll briefly introduce system resiliency as part of our agenda. Second, I'll also touch how a system is resilient with 4 characteristic functions in resistance, detection, reaction, and recovery. Just a few concepts that I want to introduce in this talk. Again, very quickly, hopefully. Last, I'll try my best to put in some principles and tips. And if one wants to dabble in this discipline in our respective organizations, perhaps a few more guiding concepts. Hopefully, there's still time for a Q&A. And a fine print. Again, in the interest of time, we won't cover organizational resilience, which is a very larger and broader topic. And I'll try to steer away from the nuances of InfoSec, BCP, and DR overlaps. These are basically part of the resiliency discipline, but since you already know most of this, I will focus mostly on the other aspects pertaining to handling of like transaction volumes, perhaps black swan events when it comes to making your systems resilient. So, okay, resiliency. So one quick Google of resiliency says that it's about basically toughness, that characteristic ability or capacity to adapt and recover from challenging situations and adversities. It kind of feels existential. But when we're talking about resiliency of systems, think of how your systems reacted during March of 2020. Did it falter? Did it bog down? How did it handle it? Because of course, we're all hoping that there won't be another pandemic, but that won't be the last challenge to the systems that we're developing or maintaining or building even for the future in a very, very fast-paced digital space now. So what makes a system resilient? Let's just get right on with it, but don't mind the image. A system is resilient if it continues to carry out its mission in the face of adversity. It's that simple. There are various types of adversity that a system can experience or be subjected to, some of which you guys are already familiar with and have put the necessary controls already for it to be in some form or shape resilient. For example, adverse effects to systems are input error failures, where some can be covered and addressed with quality assurance discipline. Resilient systems should have exception handling that can withstand or handle the weirdest human inputs and the most erroneous API calls. Another adversity, like I said, is transaction spikes, known to e-commerce sites as 1111 or 1212. No? So while capacity planning and performance testing should cover this, spikes are a headache if the assumed daily traffic, for example, happens in a matter of minutes instead. I mean, if you capacity plan, for example, 1 million a day, but for some weird reason, a million transactions just happened in a span of 5 minutes, can your system withstand it? Is it resilient enough to handle that kind of spike? So other adversities that your system should be resilient to handle are also, and not just external factors, some are housekeeping failures. When your maintenance scripts fails, bad deployment parameters, like I said, internal, especially for your user configured systems. A lot of systems now have that kind of flexibility, but not all systems are basically tested or at the very least prepared for the weirdest configurations, because it's basically a matter of multiple combinations or permutations that might not be properly tested for a system. Sometimes user flexibility is a system's worst enemy. No? Cyber attacks, everybody knows this. Age-related failures. So another adverse effect. No? So whether end-of-life dependencies, for example, Python upgrades, Kubernetes upgrades, these minute details that you don't normally pay attention to, they will bite you in the ass if you're talking about 5 years down the road, you're still using a 2015 version of some tech stack. Of course, age-related failures might not be just related to licenses and EOL or end-of-cycle technologies. It can also be a simple database build up over time that causes it to bog down. So like us aging adults, this is actually one of the system's worst enemies when it comes to making sure that it is continuing to carry out its mission. Tampering, when somebody wants to cover their mistakes or whatever malicious act that can be done internally, some systems basically are not tested or designed to handle these kinds of threats. And basically, it fails when faced with this kind of adversity. Lost communications, otherwise known as walang internet. So resilient systems should be able to work offline if applicable. or at the very least, make the user experience still acceptable and not clunky during this time. I guess there are a lot of adversities, but this one is my favorite. Black swan events, those inevitable events that somehow cannot be planned for, like, COVID-19. And basically the residual effects of that kind of global event that just trickles down into all our systems, if not just our lives. So let me just digress a little here. It's always funny that software systems and basically all of these products follow construction paradigms, enterprise architecture, software engineer, technical blueprints, because I mean, most of these bridges, infrastructure, buildings, we want to never fail. And basically, that's why I want to just emphasize where resiliency in terms of our systems and engineering should be patterned, or at the very least modeled against. So you don't want your building to like collapse with volume, but basically that's why I think a lot of these parallels between systems engineering and construction are being made. Anyway, going back to Black Swan events, allow me to digress a little, just to like make a point, or just try my best attempt to make this light. So this picture, so there was once a bridge in the UK built on 1826. Sorry, this example takes us back several centuries, and it was one of Europe's first suspension bridges. It's actually a very celebrated engineering feat at that time. So it was fine and working for 5 years until a weird event happened. No, so a troop of 74 soldiers marched on it, causing its collapse. It's not the load per se. It was already planned and engineered actually for more than 74. No, but the bridge faced an adversity. Sort of a black swan event, but you cannot really plan for this at that time. And eventually it cannot withstand it. So what happened? It was not the weight of 74 troops that caused the collapse, but 74 troops marching in sync, in cadence, that caused the chain suspension of the bridge to basically resonate and vibrate together with the left right marching of the soldiers. Nobody could have prepared for that. It's actually a weird event. And basically what happened was the bridge started to vibrate again in sync with the cadence of the soldiers when they were marching. I think when I read this story, it was even said that the soldiers also noticed the vibrations, but took it light enough even to whistle to the vibrating phenomena that they were basically experiencing at the time at Broughton Bridge. But yeah, luckily nobody died. But this was I really like this example, because nobody really can plan for these types of events. It's really weird. Actually, it's really weird and funny, because the solution after that, the bridge was repaired, was to put a public service announcement when basically using that bridge that say all troops must break step when marching over the Broughton Bridge. Anyway, I just like this engineering story. So, but basically, resiliency when it comes to building systems is actually taking into consideration, at the very least, how to not just, resist, but basically react so that, loss of life, or at the very least, loss of service for our systems won't be a matter when such events basically occur. No? So going back to our systems, imagine a system operating normally with fluctuating traffic. Just try to imagine this is the traffic or the usage, for example, of an e-commerce site. No? So one moment, the usage spikes, causing a crash, or maybe just an adverse effect on how much volume it can handle post-crash. So normal processes, or your normal reactions, or basically safeguards when it comes to organizational processes, is to investigate the crash, maybe try to fix and recover. At some point, maybe trigger a DR or some form of business continuity, which may be a manual workaround. Doesn't matter, can be a new instance, up to the point that the system can basically recover. But during that meantime, it's going to be an alternative for the system to function. At this point, basically, the resiliency is maybe non-existent or very low to such spikes or adverse events. No? So a resilient system should be able to resist these types of events. So for this case, a spike, such that even if a spike or basically a high usage event becomes the new mode of normal, to borrow that term before, there would be no need for investigations, BCP, or DR activations. So this resilient system is called resistant. No? So please remember that term, or it has the right amount of resistance in it to be resilient. So so for context, perhaps this e-commerce system is running only on 30% capacity in its normal previous operations, and a spike, despite being a dramatic increase, only consumes 70% of its overall capacity. So it is resistant to the fluctuations or spikes that it hasn't been experiencing before. So this one system is resilient. This is basically just buffer resistance, and it's resilient enough for more capacity. We'll touch on this more later. So like I said, a resistant system can handle adverse conditions and still operate normally, but not all systems can have ample resistance. After all, for volume spike events, the best resistance basically is buffering or over provisioning, which is a very expensive practice. I mean, I can buy, for example, a very small server for very small traffic, or I can buy a big server for small traffic in anticipation of those events. It's very expensive, but it will offer resistance and some form of resilience. But not all systems can afford that additional overhead, or not all companies are basically that loose with their budget. So for cases wherein solid resistance, it's not viable, a different approach for system resiliency can also be done. No? So for an unknown adverse event, detection controls can be put in place such that we can still allow the system to fulfill its mission. I'm just putting words into this resiliency topic or discipline, but most of, your NOC, SOC, DevOps, IT Ops, whatever your organization is calling it, should already have this kind of alarm systems and detection systems in place. More often than more often than not, though, these are almost geared towards these detection systems are most of the time geared towards security threats and basically system errors that are related to functional requirements of the system or expected behavior. Like I said, resiliency is about covering unusual adverse events. So most of the time, detection fails when we're talking about huge volume spikes that haven't been imagined before, for example. So in a resilient system, I mean, detection is the first step, but detecting adverse threats should also allow for a resilient system to react. So reaction controls can allow the system to continue to operate, but perhaps in a degraded or controlled state. Like, for example, most of you guys probably know the concept of throttling. If basically we're experiencing spikes, you already know that your system can only handle, for example, 100,000 transactions at any given time. And you already detected that you're gearing towards that 90 to 100,000 threshold. You would like to react. A resilient system would react by throttling the rest of the transactions so that you won't breach the 100,000 threshold. So the important thing for a resilient system that can react is it has basically the capability, if not the intelligence, to change course and manage whatever threats that they have detected that would basically hamper or even worse, cease the operations of such a system. Of course, we wouldn't want this degraded mode of operation to last that long, especially if services are affected. Resilient systems should also be able to recover from the degraded mode or the reactionary mode so that it can resume operations. So basically, resilient systems are characterized to have resistance to adverse events, if not at least detect it. So that's resistance, detection, reaction, so that it can still function even in a very degraded state. That's acceptable, of course, and eventually recover from it so that it can resume normal operations. Okay, just bear with me in this slide. It's going to be full of text. This is my best effort to cram resilience in an hour of presentation. So I'll just read through this and include some engineering techniques for resiliency. If you're technical, some of this will be very familiar. So again, resilient systems are basically characterized by these four set of additional functions and controls. So I'm just going to define it, and then I'm going to go through the techniques. So resistance is the system's ability to passively prevent or minimize harm from occurring during the adverse event or condition. It can withstand it with no need for any reform of reaction or recovery. So basically, the techniques that are commonly associated for resistance, like I said, is about over-provisioning, basically putting those buffers in place, or for more sophisticated or more modern approaches for cloud computing, using that elastic architecture that these cloud services are giving us. For example, AWS has all these sorts of elastic services that at some point, if you're already reaching a certain threshold, they will just provision and instantiate more services to cover this additional overhead, so that the system will continue to operate. Detection is the system's ability to actively detect loss or degradation of critical capabilities. Techniques here, your standard logging. Hopefully, it's becoming a discipline. And of course, your traditional alarms for your knock or SOC capabilities. Nothing new here. But again, this should be a discipline and a practice that should be religiously observed if we want our systems to be resilient, not an afterthought. Once you detect a resilient system is characterized by how it reacts. So it should be able to basically pivot, maneuver, any form of reaction to an ongoing adverse event, or respond to it, to the existence of all of these threats or unwanted events, such that basically the intention is to avoid, mitigate, if not entirely eliminate these conditions. So techniques here are basically a more disciplined exception handling. Like I mentioned, throttling, and for some cases, rerouting. So for example, if your normal route for a system is from A, B, or C, once a system detects, for example, a weird event in the node or microservice, for example, A, rather than routing it to B, you route it to a new service that mimics B, but it's entirely different from its normal route. Let's just call it A to D rather than A, B, or C. Last, recovery. It's the system's ability to actively recover from harm after the adverse event. Most of the time, basically, you want to reconcile, reprocess all of this backlog, for example, that you had to take in because you were operating in a degraded state. Techniques here are basically queuing. Of course, if your degraded state can only handle, for example, a fraction of your original service levels, you want to queue the rest that you are not able to process in that degraded mode of operation. You want to reconfigure so that, of course, whenever all of these applications are basically in the state of, for example, I can only handle this, a recovery system should be able to reconfigure it back to its normal mode of operation and not be in that state of degraded volumes or services. And during recovery, normally you over provision so that you can catch up for those things that basically were put on hold or queued, so that you can restore normal operations as soon as possible. No? So keeping in mind, these four are the basic requirements in factoring resiliency in your systems. No? So I guess that may be too technical or maybe too much information or principles. This is the next or the third act of this Graham presentation. And this should be a little more light, no? So what does engineering resiliency more for our organizations, no? So if you arrived early for this talk, there's this looping video that talks about the Boitis group as a tech-glomerate. So we are basically saying to the world that we are tech-driven, and behind all these technologies should be solid engineering practices. No, a lot has been said between digital transformation and agile ways of working, but we also have to ensure that and have resiliency in mind so that whatever products that we build and services that we conjure in this transformational journey in this fast-paced digital space remain reliable in spite of adverse events for our customers. No? So in the succeeding slides, I'll mention a few quips, some principles, and a few real-life examples that I personally had, so that guys can find the inspiration, if not the direction, to start making your systems resilient. No? So be mindful of growth targets on strategic initiatives. For the most part, you need to translate revenue targets to actual volume traffic usage numbers. Sometimes, for example, especially during this budget planning, a lot of talk has been, what's your 5-year plan? If we're earning X amount of USD this 2023, how are you projecting for 2028? Is it 200% growth? What does 200% mean in terms of volume, traffic, usage numbers for your system? Does that translate to 2 times? Like it has a correlation of 1, or it has some other form of relationship? Maybe double the revenue would mean 5 times the volume or 5 times the usage. Of course, you need to ensure that after knowing this, your systems can handle that kind of load. If we're talking about strategic initiatives, there's always that level of ambition. There's a lot of X being thrown around. UBx is at 10X ambition. Some more steady organizations would probably look at 20-30% increase of revenue. How does it translate for your systems? You need to be cognizant of that, and you need to ensure that your systems are resilient enough to handle that growth. Communicate targets and numbers that might affect adjacent systems. This I cannot emphasize enough. Most of the time, when we're talking about growth or initiatives, we're only planning for the systems that are within close proximity of those strategic initiatives. For example, campaigns geared towards sales, we only plan for the actual channels like e-commerce sites or your first level touch points. But when driving growth in these systems, it will also mean that your BI tools will have more data, your FMS will process and analyze more data. This adjacent systems I'm almost sure becomes an afterthought when we're driving aggressive numbers. But remember that, I mean, if we make our e-commerce resilient, it can handle the traffic, maybe that the growth targets are basically asking it for, but all of the other residual systems might be the cost, might crash because of that kind of growth if not properly communicated. Remember this, smart talk. So this was around 2010, no? So Smart basically launched their unlimited call promotion. I was part of Smart back then. Calls were expected to skyrocket, no? So do system traffic and all of the other residual effects. Actually, Smart planned for and provisioned the necessary infrastructure to support the spike in usage for the network, the charging, and most other systems, except my fraud management system. So basically, at that time, maybe deliberately or maybe they just forgot about me. The increase in Smart Talk traffic did not collapse my system, but it did collapse the 10 Linux servers. Imagine, it's not my system that collapsed, it's the actual servers who were crashing at the root level. For those who are technical, if you want to list the files in a directory in those servers, it will crash. The servers will crash. It was a catastrophe at the time. So this is an illustration of what happens when strategic initiatives are basically not cascaded to all the residual systems, such that, you know, it will handle or be resilient enough to cater to the increased requirements or the new mission of that system. Okay. Next, and I guess this is where it should be a part of your process na, and not just a part of, like, you know, the system's characteristics and functions. So make resiliency engineering a part of your SDLC. So establish non-functional requirements pertinent to resiliency whenever applicable, of course. I mean, and test it the same as security requirements. I mean, I've seen some application security guidelines. These are very nice as part of your scoping and user stories, but it should also include a resiliency set of requirements that are geared towards throughput or TPS, latency or turnaround time, and the degrees of availability for your SLA. Of course, for Agile, we cannot always plan for these long-term problems or events if we aim for speed, but do have the discipline to include it in your backlogs at least. Sprint plannings and retrospective should also look at potential pitfalls that will be performance related, traffic related, or any adverse events that you really don't think about when building that minimum viable product, but will be a very big headache should your MVPs go to market basically becomes unexpectedly fast. So when applicable, put your resiliency requirements in the backlog. You don't really need to do it in your MVP. You don't need to put it in your sprint 1, 2, or 3. But otherwise, once the MVP and all of these functionalities have been addressed, put your resiliency tracks for your sprint 7, 8, or 9 when your user requirements are, of course, very light already. So furthermore, once you put this in your software development lifecycle, you want to establish performance benchmarks, and of course, always test it. Include performance testing and vulnerability testing as part of your system's release cycles, if applicable, especially if you're not yet doing it. If not, put it in the backlog and schedule it post-implementation. I think most of us are already cognizant of this, no? But the next one, I think, is kind of a taboo practice, but I actually almost always do it. Whenever you do performance tests, most of the time, the devs and all the business, they schedule it in a dev environment that resembles nothing like your production environment. But I actually recommend regularly scheduling performance tests, of course, in a very, very disciplined manner, such that you won't be put in the crosshairs of your risk and compliance teams, such that you can actually gauge and be prepared for any spikes that you wouldn't really catch in a sandbox. So this one has to be this one has to be designed properly, but I recommend doing it at least twice a year, so that you can have a better picture of what you're not getting in those sandbox testings. So let's just digress a little now. So remember this. So this graph indicates basically a decline in stock price during the pandemic, no? But that doesn't mean it's a decrease in volume for stock trading. Because in stock trading operations, volatility means more activity. So more people are selling when prices are dropping, and more people are buying to take advantage of the situation. So suffice to say, when I was working at SIBO for the Tokyo and Sydney markets, this was March of 2020. So normal trading volumes before the pandemic was around 70 to 90 million transactions per day, peaking at 9 a.m. and 3 p.m. respectively. The pandemic caused the markets again to be volatile, and a lot of people already know this. A lot of people panic. Overnight, our transactions more than doubled. Suffice to say, we over-engineered the systems because we already handle hundreds of millions of dollars per day of liquidity. And basically, it was a system that resilient enough to handle even the pandemic. Why was it resilient enough? Because we do our performance testing in production weekly. That's a luxury that we can afford because stock trading operations will only occur during Monday to Friday. During weekends, we almost do performance testing in production. So find those windows where you can test in production, and you will be at least you will be prepared for this kind of weird volumes or events that normally you wouldn't catch if your performance testing is done in a sandbox. This is my last slide. So basically, all of this religiously gather and analyze data. For example, you cannot really prepare for those weird events, but at the very least, you want to be as informed as possible when you want to forecast for the scale that your systems will grow. No? But that doesn't apply in actually for forecasting. Your IT ops and DevOps teams should regularly gather and analyze data as frequently as they can check the alarms. Why? I mean, all of these exceptions are already flowing in. You're already familiar. But the events that will test the resilience of any system are not gathered, or at least not being described properly in those alarms. Subsignals for adverse events are not seen and not available, but trends coming from the data that are just like lying there and just ripe for analysis help detect such events too. So that's it, guys. So I hope it wasn't too much for a Monday afternoon. Like I said, I was hoping for something light. But this is my best effort to cram a very large discipline in this presentation. Of course, if you want to factor this in, it's road mapping and budget season, and you want to put these requirements or this kind of practice in your tech roadmaps in the future, just give me a shout out and I'll be happy to discuss more. So thank you.
All right. So thank you so much, Sir Jose, for giving us valuable insights on IT disaster recovery. I think this is indeed a very meaningful topic, especially that Aboitiz Group now is gearing up towards transforming into a tech conglomerate. No? So many factors that needed to be, mixed into the equation so that we can, be resilient in our organizations. Yeah. So yeah, we have questions. Now we have some questions from the audience. It's time for our Q&A. First up, are intelligent systems more resilient, or not all resilient systems are intelligent systems?
Let me just process this.
Yes.
Kind of like a tongue twister right now. Okay, intelligent systems are more. Of course, I think it's in my last slide that most systems, or at least practices that have a lot of data and the analysis of that data are being processed, analyzed, basically can if not detect much of these threats, can give you a sign of things to come. That's actually one of the things that make a system resilient. And most intelligent systems that I know are very much rooted on data, whether that be a business intelligence that looks at your logs, performance, and all of these other infrastructure metrics, or at business metrics that are basically about the ebbs and flows of your volume, for example. It's always really nice, or not nice. It's really a good practice to put data into your intelligence so that your systems can handle all of these other unexpected events that you have no knowledge of, for it to be resilient. The other, or not all resilient systems are intelligent systems. How do I answer this? It's kind of like a trick question. I think if when we talk about resilient systems, it can basically handle anything thrown their way at the very least. It's 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 not a boolean. It's not, this is an this is a flaky system and this is a resilient system. But at the very least, there are degrees as to which you can build your resistance, your capability to detect, your capacity to react, and how you recover. So all of this would require, for example, the reaction part and the recovery part. You have to put, these are not functional requirements. These are non-functional intelligent requirements that I think is what the question is about. So I think also the resilient system should have very much intelligence. I'm not sure if this is artificial intelligence. If that's the case, then it's not. Not everything will be artificially intelligent. Some will be just programmatically embedded in it. Okay.
Okay. Thank you, sir, for answering the question. I hope the answer was clear, no, for everyone.
I see this question. AI. This is actually an interesting one.
Okay. So let's go to this question po, sir, no. How can emerging technologies such as AI be applied?
Yeah, I think we're not talking about generative AI per se, but more of the traditional or conventional AI, if there is such one. So I think around 2015, one of the concepts of self-healing networks and infrastructure has already been introduced. So this is not just an emerging technology. This is a technology that is already out there. It's quite expensive, but basically your knock and sock capabilities are put behind not just a screen for your DevSecOps to see, but for an AI that basically analyzes threats before it even happens, not in a cyber threat way, but for example, these self-healing networks would detect if your disk is running low, if your DB is already having all of these connections not being cleaned up, and it does the same things that your traditional systems administrator would do without human intervention, because these are already scripted. So there's a lot of this it's called the self-healing networks then. So, but I'm guessing most of our cloud providers, AWS, Azure, and GCP, also has this already in place so that, it can be abstracted from our, day-to-day jobs, basically having AI replace most of that kind of health checks and O&M work. I love that question.
Yeah, so basically, sir, no, it's more of the AIs when it's in place, parang they're the ones doing the resiliency checks or anything related to that. Okay, thank you for answering the question, sir. So next is, how do you handle systemic risks in these integrated systems for clients?
How do I handle systemic risks? What do you mean with this? Let me try to interpret this as but I guess when I look at this question, it's about I think this may be related to those cascading or adjacent effects that I mentioned. Really, first and foremost, you should be one should be aware of those. I mean, for example, if I design a system that has a very public API, I wouldn't know half of those that will access it, or the systems that would consume the information, if I don't have this kind of like access control. If it's just very public, for example, your Google APIs, all of this Amazon APIs in their marketplace, when they built their systems, they wouldn't know how you would use it, how those many startups would basically try to take advantage or benefit from all of these APIs. So I won't answer that but at the very least, if you have a closed loop system, you would know the systems that would inherit or at least use your APIs, or those that will basically benefit from your data. If it's going to be something like a downstream application, like I said, it's very important to communicate with the other parties, because if you guys, for example, is systemic risk when it comes to like increasing volumes, you would want your partners, all of your other residual systems, to know that you guys are going to not just increase your capacity, but actually are expecting volume. It's basically as simple as that. I hope I answered the question to the best of my understanding, no?
Thank you, Sir Pancho. I think naman po it was already discovered by the answer, kasi it's more of the way I understand it, it's more on you connect with each other in the systemic risk. So yeah. So next question po is, hi Sir Pancho, thank you for the very interesting and informative session. If your critical systems are already hosted as SaaS or software as a service, and the underlying tech stack are not in your control, how do you ensure resiliency? Should this just be handled by contracts and SLAs, or should we go beyond what is provided by our service providers?
I love this question too. So I already mentioned that or at the very least, the more common resiliency requirements are kind of like addressed by or provided by the likes of AWS or GCP or Azure. But there are also, and for example, I really AWS, no, so Lambda, for example, yung mga Lambda na services, it's the serverless. I don't know, you can't really put the same resiliency controls that normally you would put in, like, in a Unix box that gives you a lot of flexibility when handling those processes. Pero there are a lot of these services that basically offer containers already. So rather than use your tradition, and I sana masagot ko yung tanong mo, rather than use the vanilla services, if you really want some semblance of control in your tech stack, try to use containers. So at the very least, you will need to learn a little system administration, maybe dabble in Linux more than the comfort level that you're accustomed to, but that would give you control. Of course, like you said, contracts and SLAs, always something, pero right now, if we're talking about several degrees of nines, when it comes to, for example, uptime, I think most of our common cloud service providers are already giving that because they're big tech, they can do that. It's going to be a trade-off, for example, because if you're going with contracts, there's also the possibility of just possibly terminating it. Can you do it yourself is always the question you need to ask. Can you guarantee, for example, if my tech team is only as small as a 40-man shop, how many degrees of nine can I guarantee if I'm going to operate a data center, for example? Whereas if I know AWS Singapore employs thousands of these engineers, they can go beyond what I can offer in terms of SLA. But yeah, I hope I answered your question. I think I answered your question first in terms of like bypassing the control by using containers rather than your traditional or vanilla or off-the-shelf services. And I think when it comes to SLAs and contracts, you really have to balance it with what you're capable of doing without those service providers. There's really no one absolute question answer to that question. But I like that question. Thank you for asking that.
Yeah. So I guess the takeaway there is it also is based on how big or how small your organization is po, no, Sir Pancho. Yeah.
Yeah,
So
just to add, no, siguro, I think I didn't cover it sa mga slides. If you're in an MVP state, if you're a startup, forget resiliency. Don't even bother. You want to make sure that all of your resilient endeavors are for those business outcomes that really matter in terms of, like, I cannot lose this service, I cannot lose this client. And this will always be the counterweight to the investment in this kind of engineering. If you're exploring, don't even bother right now. This would really take much of your budget. This will introduce a lot of backlogs. But once you see growth and once you see, a certain level of SLA or reliability and availability is already being asked of your systems, resiliency should always be another counterweight when you're budget planning, asking for more time from your development teams or your DevOps teams when building that tech program.
okay. So thank you, thank you, Sir Pancho, for answering our question. So we'll go down to our last two questions for this session. So what are things to look out for when doing performance tests in production?
Okay, I think first and foremost, be mindful not to break anything. It's production, so take extra care. Take triple the amount of care when touching it, because I'm just gonna assume the person who asked this would be somebody who has access to it. But if you don't have access to it, make sure that you have somebody, an ops person, that can undo whatever things you will implement during this performance test. No, okay, that's the first thing. No, other things you want to look out for. Normally, when you do performance tests in a sandbox, it's a controlled environment. I mean, for example, if it's going to be apples to apples, for example, this is the amount of memory, this is the amount of nodes, this is the amount of computing resources that you already threw at your sandbox. which is a complete replica of your production, then really what you want to look out for in doing this performance test in production is just what you want to know coming out of a smoke test, for example. Whatever else that you haven't really replicated, you will see hopefully in this kind of mirror test. But that is not the case for most sandbox performance tests. For most sandbox performance tests, it's a scale down. It's just 50% of what the computing resources and in production. So some of these decisions are basically just the resources that are available to you. And during this time, you really just, like, for example, if it's 50% of production, I'm just gonna forecast and multiply that my outcome in the sandbox test by 2 to mirror it. Normally, if you're looking for resilience, if you're benchmarking it, fine. That's a good practice. But if you're looking at resiliency, you really want to subject it to that kind of stress, not just in a hypothesis, and not just in a, like, scaling down and then just multiplying it by a factor of. A lot of things will really come out when you subject the kind of stress in production that are not in your sandbox. One of my key observations, for example, is when you do a sandbox, it's a fresh install. There's really no production data because you have no access to that kind of data that's already in production. Maybe it's client information that you cannot have access in your development environments for privacy reasons. Hence, you cannot really replicate that same amount of data in your database in this sandbox. So those are one of the things that I always look out for when it comes to doing tests, performance tests in production. How does it affect the database? Mind you, though, when you do these tests for the database, before you even do it, actually, prepare a script to roll back. You don't want to touch your database and introduce dummy data in production. But I guess that's a discipline that you guys will have to figure out on your own because of the constraints that your risk and compliance team would tolerate. So work hand in hand with them, because basically resiliency is also owned by your risk team, and they will also be the ones who will allow you that kind of access to basically find out or figure out how my production systems will behave in such a test.
Okay, so thank you once again, Sir Pancho, for answering that question. Just a last question for our session today. Do SaaS already have a resiliency process along with their services or included in their services?
Most of the time they do. So these cloud services that are already available, especially if it's built on top of those big tech, like I mentioned a while back, throttling, multi-instances, distributed architectures. These are basically techniques that are involved in resiliency. They already have some form of logging, for example, for your CloudWatch in AWS, but this is mostly on the infrastructure level. Most of the time in the product level, that's really up to you guys when you build it. When your user story comes in, it's mostly functional. It's mostly about the customer journey. You don't really want to put in all of this, let's call it resiliency user stories at the start, but don't expect any product related development to be handled by most of these other SaaS, because whatever builds you're doing, it's up to you guys during the development time to factor in the resiliency that you want to be put in your systems. But yes, most of the SaaS providers already give it on the platform level. That's actually something that is quite very different when I was doing this almost 2 decades ago. A lot of this are basically you have to do it on your own, but now they provide it as part of their cloud services, which is very very nice.
Right. Thank you so much, Sir Pancho, again for answering the question. So unfortunately, we're out of time, but if you still have questions, Sir Pancho, maybe they can contact you po, no?
Yeah, Pancho at
Yeah.
UBx.ph.
Okay. Yeah. So we would like to thank everyone who joined us today, and of course, our speaker, Sir Pancho, for sharing his insights and answering the questions. We would also like to take this opportunity to invite everyone to the rest of our RAM 2023 learning sessions. So we just finished our IT disaster resiliency today. And on November 15, Wednesday, we'll have our supply chain resiliency 3 to 4 p.m. On November 17, Friday, personal resilience 10 to 11:30 a.m. And we'll be having our risk finance week on November 20 to 24. So our learning lunes will cover practical insurance for TMs at 10 to 11 a.m. On November 22, Wednesday, behavioral-based road safety for TMs at 10 to 11 a.m. So we hope to see everyone again in our next meetings in our Risk Awareness Month. So please don't forget to provide your feedback. We have flashed the screen, the QR code where you can provide your feedback. So thank you and have a great week ahead.